Okay, we're going to look at question number 21. Each of the 20 balls is tossed independently at random into 5 bins. Let P be the probability that some bin ends up with 3 balls, another with 5 balls, and other 3 with 4 balls each. Let Q be the probability that every bin ends up with 4 balls. What is the P over Q? Okay, question number 21. So let's see, we have the 5 bins. We can call this is A, B, C, D, and E. Five bins, right? Okay, so now actually what happened is here. So we're gonna find the probability P over Q. So what is the probability P? P basically equal to the total number of ways at the bottom to throw these 20 balls. So let's call the ball from number 1 to number 20, right? So each ball you can toss either into A or B or C or D or E. So that's 5 options. Then you can think of a total number of ways can be 5 to the power 20. So now then you can find the probability for P. That's you're gonna find eventually you're gonna have the number of ways. So we're gonna call the function way. We're gonna have a combination of 3, 5, 4, 4, and 4. So what about Q? Q just is similarly, that's 5 to the power 20. Total number of ways, that's going to be the number of ways. We have 4, 4, 4, 4, and 4. So if we do the P over Q, that's just number of ways, right? This is going to be canceled. If we do this, then this part canceled, right? We really just want to know the ratio of number of ways to have 3, 5, 4, 4, 4. And the number of ways have 4, 4, 4, 4, 4, 4, right? Okay, so now that's what we're gonna do. Okay, so let's look at the first case. So if we have 3, 5, 4, 4, 4, so let's just assume this in A, this in B. So how many ways to do that? Right. So we call this is W1 for this first situation, right? So the second one called W2, right? So this actually is, we have these 3, so that's going to be 20 choose 3, right? So then we have 17 ball left. So out of that next 17, we have 17 choose 5. So continue, the number of ways will be 12 choose 4. Then we have 8 choose 4. The last one going to be 4 choose 4. It's just 5 for A is has 3 and B has 5. But actually, we can have any 2 of these. Any 2 bins showing these 3 and 5. So then we need the times, yeah, because we find the number, the bins we have 3, we have 5 options. So then we find another bin has 5 balls, so we have only 4 options. So that we need times 5 times 4. So this is total number of ways. We have 1 with 3 balls, the other with 5, the rest has 4, right? So then that will be the number of ways meeting the first requirement. All right, so then what about the second one? Second one, we just need a 4, 4, 4, 4, 4, 5 fours. So then 20 choose 4. Then we have 16 choose 4. Then we have 12 choose 4. We have 8 choose 4. We have 4 choose 4. But basically they are the same. We don't care about the order, right? Each one has 4. We can take care about this. So actually we're gonna do the dividing. You do this ratio. So now you can see we're going to simplify here. So this canceled, this canceled, this canceled. So we're going to just focus on these three. So this one actually is 20 times 19 times 18, then over 3 times 2 times 1 times here this is 17 times 16 times 15 times 14 times 13 over, so 5 times 4 factorial. I'm going to write here. So over here, so that's going to be 20 times 19 times 18 over 4 factorial times 20. That's actually we have 17 here. 16 times 15 times 14 times 13 over 4 factorial, right? Then times we have here times 5 times 4. So let's just do some cancellation. You know, the top one just canceled. So we're gonna do this reciprocal and do this simplification here. So which equal to 4 factorial times 4 factorial times 5 times 4. Right, this reciprocal up. So over, so this is denominator, that's going to be 3 times 2 times 1 times 5 times 4 factorial. So we cancel this 4 factorial, we cancel this 5. So we can see this actually is a 4 times 3 factorial. We cancel this 3 factorial, we have 4 times 4. Answer equal to 16. So go to look at the question, we can find the answer is 16. Okay, so question number 22. Inside a red circular cone with base radius 5 and height 12 are 3 congruent spheres, each with radius r. Each sphere is tangent to other 2 spheres and also tangent to the base and side of the cone. What is the radius r? Yep, we need to draw a good diagram. Here is a cone. We have 3 spheres inside this cone. So basically, I think here is the diagonal. So I'm going to say this actually is diagonal of the diameter of the circle of the base circle, right? So I think I'd like you can think about a cross section here, but that's a middle, right? So here I can drop a height from the vertex, right? So you can see actually these 3 centers of ball form a equilateral triangles. So this height going to go through the center of this equilateral triangle, then continue go hit the center of the base circle, right? Base circle, right? So this is going to be a structure. This side is going to be 5. So this height is 12. And then we know this is right triangle. We have here, this is 13. Okay, so we're gonna focus on this equilateral triangle here. So I'm gonna draw this equilateral triangle. So this is the center we call A, this center B, this center C. You know, because they are tangent, so we can just 2 circle tangent. So this radius r, this radius r, right? So similarly, you can see we have radius r, radius r, radius r, radius r. So this ABC, just like an equilateral triangle with side length 2r. So now we can look at, so because this is the center, the height also goes to the center, right? So we're going to connect A and the center, this called O. So that's going to continue to hit here. So this actually is the center of this quarter, the equilateral. If this is 2r, this is r, then the height actually is square 3r. And this AO, you know this is just a property of the centroid, because this is the center, also a centroid. So this is going to be 2/3 of this this height, square root 3r, right? Okay, so AO, we're gonna mark here is O. You know, AO is the from A to O. Actually, this also perpendicular, right? Okay, so AO equal to 2 square root 3 over 3. So, and also you can see this is the center of the ball that's tangent to the bottom here. That will be R. So this also R, right? So actually we're gonna find the area with these two green part. Green. This is the height from center in this triangle. This is a height. And this height, R, is the height of this bottom triangle, cutting by these two green lines, right? So, and also this has a base 12 with this triangle with this height. Height is AO. Right. We're going to write the area. So the area of the triangle ABC, this right triangle, we have this right triangle, we have 5, 12, and 13, this right triangle. Actually, the area we find, that's going to be half of 5 times 12, right? Which also equal to the three triangle added together. The first one is half of base is 13, then times the height is R, then plus half of the small triangle at bottom, that's 5 as base, times the height, actually the R. Then we're gonna plus 1/2, this base is 12, so this height is AO, 12 times AO. AO is 2 square root 3 over 3R. Right, so then we need to simplify this. So we multiply both by 2, we have 60 equal to 13R plus 5R, then plus, so this part is 12 and 3 cancelled. So that's 4 times 2, that's 8 square root 3R. Now you can just see that's just really simple one variable equation. 60 equal to 18 plus 8 square root 3R. Divide by 2 both sides, 30 equal to 9 plus 4 square root 3R. So solve R just equal to 30 over 9 plus 4 square root 3. Then we just rationalize the denominator. So times, we have 30 times 9 plus 4 square root 3. The bottom one, we're gonna multiply both up and down by minus this. 9 minus. Rationalize, we're gonna times radical conjugate. So time bottom, that's 9 minus 4 square root 3. Right. So then we can find out here the top one going to be 30 times 9 minus 4 square root 3. The bottom one is 81 minus 16 times 3. That's actually is 16 times 3. That's 48. Right. So then we continue. This is 33. 33 we cancel, have 11. This is 10. So then we simplify. We got 11 at the bottom. Then we have 10 times 9, 90. 10 times 4 square root 3 minus 40 square root 3. So this is going to be the answer. Now look at the answer key. We have B, 90 minus 40 square root 3 over 11 is the answer. Question number 23. For each positive integer n, let f(1)n be twice the number of positive integer divisor of n. And for j greater or equal to 0 equal to 2, let fjn equal to f1 parentheses fj minus 1n parentheses. For how many value n smaller or equal to 50, is F50N equal to 12. Right. So here, I think I want you to know two basic things. So what is number of a divisor? Number of a positive integer divisor. The next one is understand what this function f means. Right. Let's see. First, we're gonna look at the number of divisor. Suppose we have the number 10, right? So we know this actually is 2 times 5. 2 to the power 1 times 5 to the power 1, right? The number of divisor, actually, we're going to pick about this one and this one, right? So this is going to be the first one plus 1 times the second one plus 1. So this tells 2 times 2 equal to 4 factors. So if I look at another example, let's see 48. 48 actually is 2 to the power 4 times 3 to the power 1. So that's actually give us, this is a 4 plus 1 times 1 plus 1. This is going to be have 10 factors. So this is how we find the number of factors. So let's look at another example. Let's see 30. 30 equal to 2 times 3 times 5. Right? That's going to have the factor. So we call d of 30 divisor of factor. So that's equal to 1 plus 1 times 1 plus 1 times 1 plus 1. So that's equal to 2 times 2 times 2, 8 divisors, right? So first one, we need to review this basic concept, right? The next one, we're going to look at what is function f1. Function f1 of n. So let's give any example. Let's say 9, right? So that means that's twice the number of divisors. That's going to divisor of 9. So we're going to find out what the number, how many number of divisor are 9. 9 equal to 3 to the power 2. So which is going to be just 2 plus 1, which have 3 divisors. So that means this is going to be 2 times 3. So this has a 6 factors. Right? So let's look at another example. So F1, let's see, we have 20. So F20 basically that is 2 times number of divisor of 20. Then 20 equal to 2 to the power 2 times 5. So which equal to which tells us there's a 2 plus 1 times 1 plus 1. So there are going to be 6 divisors. Right? So now we already understand what is F1. Right? So then these tell us we're going to do the recursion. So if we find the next function, right? So if we have F1 here, so we find the next one, that's going to be F2. F2 going to be the previous one. So you can see this is a J, this is a J minus 1. If these are 2, this is going to be F1, then is this going to be F1, then function as here, this is going to be F1 of n, right, of n. Okay. So then, because we already found this Fn here, so F1, and this is 9, right? So sorry, this is going to be 9. Then this actually going to be, I'm going to write it clearly. This actually is F2 9. So that's actually F1. F1 is corresponding to this one. Then Fj minus 1. J is 2 here. 2 minus 1. 2 minus 1. So that actually is 1. F1 9. And then this actually is F1. We already know this is 6. Then we're going to put a 6 here. F1 6. Right? So what is F1 6? Then you need to find what is like 6. How many divisors 6? 6 actually is 2 times 3. It has four divisors. That's 2 times 4. Then you find this actually equal to 8. So this is F2, right? Then what is F3 9? F3 9, right? That's going to be F1 then F3 minus 1, right? 3 minus 1, that's 2, 9. So that's actually equal to F1. So we already find this is 8, 8. So that's how many number of divisor 8 has. Right? So if you look at 8, 8 is 2 to the power 3. These tell us there are 4 divisors. So the function of F1 of this, that's just 2 times the number of divisors, twice of the number of divisor of 8. That's 4, which also equal to 8. All right, so then this moment we all know what is the number of how to find the number of divisor, and then how to calculate the f function. All right. So now look at the question. Question is how many value of n smaller or equal to 50 equal to f is f50n equal to 12. Okay, so our question about this, right? So then you can think about f50n, so that must equal to f1, then f50 minus 1, 49n. So now this actually is tell us this going to be twice of a divisor of f49n. So that's basically this, right? So that means f49n going to be in has 6 factors because this equal to 12, right? So then the number of factor of this means 6. So that's f49n must in form of either p to the power 5 or p squared times q form. Because this has 6 factor, so this has 6 factor. P and q are both primes, right? And then we're going to continue goes back. So then what about 48? So this make a lot of complexity, not easy to see through. So I think probably we can go back and then what about we can just do some pilot study, see what about 1, what about 2? Then maybe we can find out something, right? So let's see if we do F1. So if we have, we can think about n. We can think about n has 1 factors. If we start at n has 1 factor, as we're gonna use this number of factors of n. So I'll just say dn. So we're gonna start at dn. dn equal to 1 or dn equal to 2, dn equal to 3, d equal to 4. So I'm gonna just do this first try, right? So then we can do f1. f1. So example of this, so the f1, right? The function f1 of 1 basically has only 1 factor, right? Okay, so now you can see here. So that's f1, 1 just equal to 2 times 1. So then you got 2. So then we look at f2. f2, this is 2. Then that's going to be looking at the f1. So that's find how many factor of this. So that actually is equal to f1 n, right? So then this is 2. So this already got 2. Then that's f1 2. 2 has 2 factors. So that's basically 2 times 4. 2 times 2 equal to 4. So then the 4, right? So next we're gonna have f3. f3 of this number. This has three divisors. That's going to be 2 times the number of divisor of this, 2 times 3, which is 6. So continue, we have f4. f4 of this. So this has this equal to 2 times 3. This has 4 divisors, right? So this actually is 2 times 4, which equal to 8. So now what about F5? So if I have F5, so you can look at this number, F4. F4 has 2 to the power 3. It has 4 divisors. Then that's going to be 2 times 4 equal to 8 again, right? If we continue F6, let's keep giving you 8. Right? So if a number with only 1 factors, so there's no, just starting 1, right? So there's no way to reach 12. All right, so then we're going to look at 2 divisors. 2 divisors basically are all the primes, right? If we think about 2 divisors, then that's just like a prime, like a 2, like a 13. So we're just using 13 for example. If we think about 13, 13 has 2 factors, 1 and 13, right? So you can think of F1 just 2 times 2, which equals to 4. So then the F2, you're going to look at this 4, it has 3 factors, then just 2 times 3, which equal to 6. Look at this. This is going to be 2 times this has. Okay, so now we can see next level. So you can see 6 actually has 4 divisors. Then 2 times 4 give you 8, right? So continue. This has 4 factors. 2 times 4 equal to 8. So basically that's going to be have 58. You can, no matter how you continue, the F50 going to have 8 equal to 8, right? So then look at the 3 factors. Example just like a 4, right? Or 9. This is a perfect score, just have 3 factors. So then you can see F1 just 2 times 3, 3 factors equal to 6. Then continue, you can see that's next going to be have 2 times 4 equal to 8. So then you got to have all 8 beyond. So what about 4 factors? That's 2 times 4 give you 8. 8. This 8 has 4 factors. Then continue 2 times 4 equal to 8. All 8 here, right? So you can see 1, 2, 3, 4 doesn't work any for all of them, right? So then maybe we can look at the more factors. We have 5 factors. So if 5 factor, that's going to be 2 times 5. The F1 actually equal to 10. F1 equal to 10, then 10 has 4 factors, then 2 times 4 equal to 8. F2 gonna have only 8. Then next, 8 has 4 factors, then that's going to be 2 times 4 equal to 8, right? So if n has 5 factors, does not work either, right? So let's see what about 6 factors. So 6 factors, then 2 times 6 equal to 12, and 12 equal to 2 squared times 3. So these have 3 times 2. This has 6 factors. So the next level, F2 going to be 2 times 6 equal to 12 again, right? 12 going to have 12 factors. Now you can see any form in this going to give you the expect 12. F50 going to have 12. Right? So let's call this gonna be for 6 factors, right? So we're gonna find how many in 50 in later, right? So let's see what about 7 factors. 7 factors, but up to 50, the smallest 7 factor must 2 to the power 6. So actually this equal to 64. So they accept the limit. So we don't going to consider this issue. What about 8? The 8 is going to be 2 times the 8, which is 16, right? So then 16 has 2 to the power 4 have 5 factors. Then 2 times 5 equal to 10. Then 10 has 4 factors. 2 times 4 equal to 8. So you have 8 factors. Then you have 8 and beyond. So then that does not work. So now we're going to look at what about 9 factors. What about 9 factors? N has 9 factor. So if you think about 9, have 9 factor, so that's going to be 2 times 8, 2 times 9, which equal to 18. 18 equal to 3 to the power 2 times 2, So this has a 6 factors. So then the next level going to be 2 times 6, which is 12. Now you see the 12 have 6 factors. Next level going 2 times 6 equal to 12. So now you can see we have 12 all beyond. So these also work. Right, so now we look at the 10 factors. If we have 10 factors, if I have 10 factors, so then we have 2 times 10, which equal to 20. 20 is 2 to the power 2 times 5. So this is 6 factors. Then this is going to be 2 times 6 equal to 12. So F1 equal to 12. F2 equal to 12. Then F3, this has 6 factors, 2 times 6, then equal to 12. Then you can see that's going to be happy, right? So now you can see we can have up to 10 factors. What about more? So 11, that's similar as 7, that's too large. What about we have 12 factors? If we think about 12 factors, 12 factors, so that's the smallest is going to be 2 to the power 2 to the power 3 times. So we can see we can have 2 to the power 2 to the power 2 times 2 to the power 2 times let's see 2 to the power 2 times 3 times 5. So I think that this one going to be the smallest number, only has 12 factors. So this is 4 times 3. This is going to be 60. That's going to be too large. So if you look at the large number, none of them. So thinking in all, so n must have 6 factor or 9 factor or 10 factors. Then it's from 1 to 50. Then we're going to find all the numbers from 1 to 50 has 6 factor, 9 factor, and 10 factors. So 6 factors. So this, if a number has 6 factor, that's must in p to power 5 or p squared times q form. Let me clean the board first. Okay, so before we just show that n must have 6 factor, 9 factor, or 10 factor in able to get F50 equal to 12, right? So then we first look at 6 factors. If we have 6 factor, so this number must be a prime to power 5 or a prime p to power 2 times q, right? Where p and q are both prime. So then if you look at here, so this give us the solution 2 to the power 5, that's 32. So we cannot do 3 to the power 5, that's too large. Then p squared over q in this form, we can look at the 2 squared, then times 3, 5, 7, 11, and no more, right? If we do 13, that's 52. That's too large. So maybe we can have 3 squared. 3 squared can times 2, can times, can also times 5. That's 45, right? That's it. Cannot do 7. So then we can do 5 squared, then times 2. 5 squared times 2 is 50. That's big enough. So then, can we do more? Okay, I don't think so, right? So that's all in this one. So now we look at then with 9 divisors. So with 9 divisors, so that must be a perfect square because these are, right? So the simple, there's going to be p squared times q squared form. So it could be p to power 8. That's also possible. But actually, so even p equal to 2, that would be too large. The only possible is p squared times q squared. So the only one is 2 squared times 3 squared. You cannot do 2 squared and 5 squared. That's too large. Right? So then we have these as the only one solution. All right, how about 10 factors? If n has 10 factor, that must be 2 to the power, so p to the power 4 times q, right? We cannot do p to the power 9. P to the power 9, that does not work. So we can only look at this case. Right? If in this case, we can see 2 to the power 4, that's 16. Then we're gonna time 3, right? So this is good. This is good, right? So we cannot do more. 2 to the power 4 times 5, that's too large. Yep. So this is the solution, right? Now we just need count. So we have 1, 2, 2, 3, 4, 5, 6, 7, 8. We have 8 here. We have 1 here. We have 1 here. Added together, we have 10 possible integer n. So look at for how many value of n is this equal to 12. So n equal there's a 10 such number. Answer is D. Question number 24. Each of the 12 edges of a cube is labeled from 0 of either 0 or 2 or 1. Two labeling are considered different, even if one can be obtained from the other by a sequence of one or more rotations or reflections. For how many such labeling is sum of the labels on the edge of each of the 6 faces of a cube equal to 2? Right. I think here the two very important things before we're gonna look at for the solution, right? So actually the number one, so this sentence, the two labeling consider different, even if one can be obtained from the other by sequence of one or two rotation or reflection or reflection. So these just indicate each edge of each of these 12 edges are distinct, right? So any different labeling are good. We're going to count, right? Number two, so for how many such labeling is sum of these edges of each faces gives equal to 2. So if you think about this is a cube, it has 6 faces. So each face you're going to have sum of number is 2. Right? So now you can see actually if a 2 times 6, right? So we have 6 faces. Let's give you 12 counts. Actually, each edge gonna add by 2 faces. For example, if I add 1 here, so this number gonna count in this phase and also count in this phase. So in this case, this actually be double counting. So suppose we're gonna have 12 divided by 2, so that's equal to 6. That means out of these 12 edges, 6 of them gonna be labeled as 1. The other 6 gonna be labeled as 0. Right? So then we're gonna look at what happened here. Right, let's draw a diagram. So I think easy to do that, I'm gonna just draw this way. So this is a front face. So this is gonna be a the the back face, right? So I'm gonna connect here. This is gonna be the side. This is gonna be side. So I'm gonna use a different color. I'm gonna use a different color. This is gonna be the here. So just make this easier to see all the 12 edges, right? Remember, this is a front face. So this large will be the back face. So these four black, that's just at the side. This is a 4 parallel, right? Okay, so then we're gonna label it. Remember, every of these edges are distinct. All right, so now I think about, so when we label, we're gonna observe, right? Observe, so how to classify these 6 edges labeled as 1? You look at the front has a 2 labeled. We have 2 on this face. So if you look at the back, we also has 2 at the back. And then we have these 4 black. So that means we're gonna have 4 black. We need to label 2 of these black. Right? So then I think I'm gonna think about these cases, right? So first one, I'm gonna find two of these black marked as 1, right? So then you think about, we have basically 2 cases. So either we have a next to each other, we label this one or this one, right? We can label these 2. So the next case, we're gonna label the opposite, this one and this one, right? So we're gonna begin with these 2 situations, right? Let's see if we have these and this. So I'm gonna draw the other one as here. So this is for this case. I'm gonna do the other one. So we have here, we have here. So we're gonna do connect, 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 right? So in this one, I'm gonna do opposite, right? So if we do this case, so out of this 4, we're gonna do the do adjacent. So we can 1, 2, 3, 4. We can do 1, 2. We can do 2, 3. We can do 3, 4. We can do 4, 1. Right. So then the 2 adjacent parallel. Right. So then actually we have 4 such way to choose these 2. Right. This is the first step. So after we do that, we're gonna find out what about to do the next few edges, right? So once we do that, so we cannot label here, we cannot label here. So that means we got to label here. We got to label here. Right? So remember, these 4 sides, we can only label 2. So then we're going to look at the top, the front. So we cannot label here. We already label here. We can either put here or here. Right? So then these give us 2 options. So for example, we label here. So then we label here. We label here. Once we do that, so then we're gonna look at the front edge. We cannot do here. We cannot do here. We have to do here. So then we have 1, 2, 3, 4, 5, 6. We're done. Right? We're done. So this is gonna be 4 times 2. All right. So now we're gonna look at this case. So we're gonna do the opposite. Right? So we can do 1, 3, or 2, 4. So we only have 2 ways to do this step. So next step, we're gonna label. Let's see. We're gonna label. Let's see. What can I do? We cannot do this one. We cannot do this one. Now we look at top. So we can do. We can do. Let's call this is. I'm going to also call this 1, 2, 3. So on the top we have 1, 2, 3, 4. I'm going to call the so you know we have 2 ways to color this, right? So we're gonna look at the top. We call this is 1, 2, 3, 4, right? So now you can think about the second step. We're gonna pick a 2 from here. We can pick a 1 and 2. You can pick a 2 and 3, 3 and 4. Basically, that's total is 6 choose 2 ways. Or 4 choose 2 ways. But we need to guarantee each one has solution, right? So let's see. If I pick these 2, and color this. If I pick these 2, right? So this work. So then I'm gonna pick these two. So that's only possible way. So if I pick these two, we find, right? So what about I pick these two adjacent here? If I pick these two, then I cannot pick here. I cannot pick here. So I can pick. So we have here. So we cannot pick here. We cannot pick here. So that means the bottom one we only can pick these two, right? So now you can see there's exactly one solution for this case. And then similarly, if you pick a 2 and 3, that's similar for this by symmetry, right? So then what about if I pick about 3 and 4 similar? If I do 2 and 3, that's good. So we only didn't do is if we do the opposite. What about we have pick 1 and 3? If we pick 1, 3, then we cannot do this one. We cannot do this one. We only can do is this one and this one. Yeah, so we got it. So there are exactly each of these, no matter we have these 4 choose 2, there are 6 different ways. Each one will lead exactly one solution. Right. So now we can just find this. This is the 2, this is a 6. This is the 4 times 3 divided by 2, this is 6, this is equal to 12. So then we combine these two situations. In the first one, we got 2 times 4 equal to 8. So we have here 12. Added together, we have total 20 different ways. The answer is E, 20. Question number 25. A quadratic polynomial px with real coefficient and leading coefficient is 1 is called the respectful if the equation px equal to 0 is certified by exactly 3 real numbers. Among all the disrespected for quadratic polynomial, there is a unique such polynomial p with x for which the sum of roots is maximized. What is the p with 1? Okay, question number 25. A quadratic polynomial px with real coefficient, leading coefficient 1, right, is called disrespectful. Okay, so I think that for this one, I think most important thing is what this means. P of px equal to 0. Right? We know px is a coefficient, leading coefficient is x. So that's px going to be kind of a px, x squared plus bx plus c like, right? If a graph, there's going to be a curve either here or here, or maybe touching at one point, right? Some kind of this, right? But p of px, so p of px, basically, you're going to plug in x, you find the sum of this x, then you plug in here. So this equal to 0. So if we look at this situation, we have 3 of situation. If we look at here, so because we have px, no matter what you give px, so then you can get output that's called k. So if we do k, so px, that's going to pk going to equal to 0. But actually, if in this situation, use this curve, that's never going to reach 0. So then you can simply eliminate. That's not going to be this case, right? So that means if you have these two information, we know px at least going to be intersect x-axis, going to have a 0, right? So now we can simply assume px has a real solution we called r and x. So we can simply write in factor form, x minus r times x minus x. So this is very important. So this px must at least one real solution or two real roots, right? They could be identical. We call R and we call the other called S, right? So if we graph this graph gonna be just like this, right? So let's see. If I graph this graph actually gonna be like this. Just like this. So we call this side gonna be R, this side gonna be S. So then we have this graph, right? Okay, so now what happened next, right? What we're gonna go back and look at what this means. P of px equal to 0. Okay, let's just write px first, right? So we're gonna say ppx. So that's by the definition of composition, right? So then we're gonna replace this x with px. So every x with px. So that actually is a px minus r and px minus x. So this equal to 0. Now you see actually this tell us just px minus r equal to 0 or p equal to r. Px equal to r. And or px minus s px equal to s, right? So this basically the solution here we're gonna have two solution from here. So these have a two solution or so actually so we have two roots here because px is polynomial and px equal to s also has two roots, right? So these tell us. So then we can look at here. So this actually this one 35 by exactly three real numbers. Three real numbers. So that means one of these gonna have two identical solutions, right? Two identical roots or one solution. We call this has a one solution, then this must has two distinct solutions. Okay, so then if we look at this one, if this has px equal to r has one solutions. When this has one solution, that means, yeah, so then this only possible has one solution that's intersect with this one. So that means when this just equal to r. So this actually equal the value is going to be r. And so this going to be at the vertex. So this px equal to r shows this actually has a value r as a vertex, right? Okay, so then because this is also the vertex, also the symmetrical line here goes to this. So you know this actually is r plus s divided by 2. Right? So then we can write this as only just like a px here. So this px can only be x minus r plus s divided by 2 squared, then plus r. So this is the px for this part. Only be this part, this kind of thing. And from the beginning, so we know px also equal to this, right? So that's actually tell us r is a root. So that means if we plug in pr, so this actually equal to 0, which equal to, we're going to replace this with r minus r plus s over 2 squared plus r. That must equal to 0. Right? We're going to simplify. So this is going to be r minus s over 2, then squared equal to plus r equal to 0. We can solve this s in terms of r. So then we have r minus s over 2 squared equal to negative r. So then we do square root. So then square root negative r. So we have r minus s over 2. So of course we have positive negative here, right? Right. So now we can think about next one. We're gonna look at solve s. S gonna be equal to s gonna be equal to that's gonna be s equal to, let's see, we multiply both sides by 2, then 2 plus minus square root negative r, then r plus 6. Yeah, r plus 6. R equal to this is a, I'm gonna put it, this is positive negative. R plus minus 2 square root of negative. So then we find this actually. Right. So now we're gonna look at another situation. We want the here the among all these respectives, there's a unique such that polynomial px, which the sum of all the roots is maximized. So we don't know what is the sum of roots yet, right? So we can look at here. So this one, so we have px equal to r. So we're gonna write this out, right? Within the first one. That's basically x minus r times x minus s equal to r. So this is gonna be x minus r times x minus s equal to s, right? So if you expand this gives us x squared minus r plus s x with the remaining part equal to 0. This will be the same, x minus r, x squared minus r plus s, x plus etc. equal to 0, right? So you can see in this equation that the two roots are the sum of the two roots. We call r1 plus r2 just equal to r plus s. Similar is here. This r3 plus r4. So although we know this r1, r2 is this is identical. So this also r plus s, right? So now basically actually the sum of all the roots r1 plus r2 plus r3 plus r4 is just equal to 2r plus s. We want this be maximized, right? So now we have this expression. We're gonna work here, find a maximize of the two of these. So we're gonna plus r both sides. So now you can see we have 2r here. So we're gonna times 2 here. So that we have 2rs. Then this can become 4r plus minus 2 square root negative r. We want maximize, so we don't want this minus here, right? Then let's give us smaller. So basically we have 2r plus s. So that's equal to 4r plus 2 square. So this is also 4. This is also 4 square root of the negative r. Right, so I think we can just make a perfect square here. So this basically we can see, you can see negative r square root. So then these actually we can just make a this gonna be a minus 4 negative r. So negative r must be positive, right? So then plus 4 square root of negative r. So we can use in square root of negative r equal to a. We're gonna do such substitution. So then that's equal to negative 4a squared plus 4a. So we're gonna minus 1, we're gonna plus 1. Right. So then we can find this actually equal to negative 2a minus 1 squared. So this is gonna be actually minus 1 squared plus 1. So this is a perfect square. We're gonna take out the negative side. We find this perfect square. Then this has a minimum value when is 1. When 2a equal to 1. 2a equal to 1. 2a equal to 1, then find a equal to negative equal to 1 half. All right, so now we can go back here. If n equal to 1 half, and square root of negative r equal to 1 half. So then we have negative r equal to 1/4. So we can find r equal to 1/4. So we can find s. So s equal to, right, so we can just find this maybe somewhere here. We can find, yeah, let's see, we can, and here we have s equal to r plus 2 square root of negative r. So that's what we have, right? So then this is 1/2, this is negative 1. So we have this one r is 1, this is negative 1/4. Negative 1/4 plus 2 times a half, plus 2 times a half, so which is 3/4. So we find s equal to 3/4, r equal to negative 1/4, then this is right. So then we can find px. Px actually equal to x minus r. R is negative 1/4 plus 1/4, then times x minus s. S equal to 3/4. So then we can find P1. P1 equal to 1 plus 1 over 4 times 1 minus 3/4. So which equal to 5/4 times 1/4, which equal to 5 over 16. Yep, we check, we find answer is A.